Hi. As we start week two of our quarantine lessons, I hope you and your families are doing well. And thank you for sending in questions. As you know, I'm constantly checking, even over the weekend, Saturday and Sunday. I had responded to some people's emails and text questions. Actually, there were even driver's ed questions that people sent to me on the message board in Edmodo that I responded to. So if you feel that you want to ask me a question, go right ahead. And yes, Andrew, your dog's haircut looks spiffy. I saw it, and he's looking very, very cool. So, guys, I am looking, I am reading, I'm commenting on everything online, either in the video sessions or sometimes I respond directly to you via email or Edmodo. So this is our means, and we're going to continue to do it. One person did, in fact, message me that I made a mistake on question number 15. Question number 15, I didn't bring my book over. Let me get it. Question number 15 asked me about the products of an acid base neutralization. And I went ahead without reading the question carefully, and I said, oh, it's salt and water. So, let me see. And the salt would be NaCl. And I chose NaCl, which was choice 4 for the answer. But someone messaged me back and said, hey, Mr. Castle, question number 15, you know, I think the answer was water because they didn't ask for the salt. They said a salt and again, like I do this in class all the time, and I say the same thing to you. When we answer our questions, reading is fundamental. You have to read carefully. I definitely did not read carefully. I read through the question very quickly, and I simply went actually to the harder answer, determining what the formula for the salt was, and it was NaCl, but all they wanted was a good old H2O. So the actual answer to question number 15 was choice 3. And question number 20, even before you clicked on the video link, I put a notice up because as soon as I answered the question, I didn't want to have to, I can't correct just the end. At least it's not within my ability to edit a portion of it. I would have to do the whole video over to make a correction to the very last segment. So I decided to type the correct answer in with the link to the video saying that the correct answer was 1.8. But I'm going to start with that, solving it, giving the answer, and then go through the rest of the questions, or as many as I can. I don't like the videos to go much over 20 minutes because I'm going to work on the assumption that you're going to watch the video, stop it, look at the question, and it's going to take you guys probably twice as long to go through the video. So I'm trying to keep them in the very low 20-minute range. So I'm going to do that, keep this to the very low 20-minute range. Again, so I'll do as many as I can. I'll do one more for Tuesday morning. And then remember, Tuesday you have to take the test, all right? Some of you did already. About 5 people did. And I know one person did and didn't answer any questions. They did reach out to me via email, and I said, I'm going to see what I can do. I don't know if I can reset that test. I might have to make a new test for them. I'll figure it out. That's something I'm going to have to do. You guys actually don't have to worry about it. I do want you to know that once you start, I think it's 30 minutes. It's timed, and after 30 minutes, you have to, the test ends. So I know some of you are very time conscious when you're taking your test. You got to finish in the 30 minutes. There's reasons for that. I do scramble the questions test to test. So, but if 2 people are trying to take them in the same room, you can start comparing answers back and forth, skipping and going back. You can't do that. You got to go one to the next. We've been told by administration that we have to have some verification of the grades. So I'm trying to do my part by trying to keep the grades authentic. That's why we have the timed exams and the scrambled questions. Also, the taking of the attendance. Friday's lesson, only 14 people logged on to as of now. Now, I realize you can still log on to it tomorrow, but you guys are supposed to log on a daily basis. So 14 people, well, you all might have logged on. 14 people liked it, okay? That means there were 11 people that might have looked at it and didn't like it. So I don't know. I can't verify that. You make sure you go on it and you like it so I can take attendance. Because if a lot of people aren't taking attendance, if I can't take attendance for a lot of people, I'm going to have to report it. I've already made some phone calls home. Those of you that got phone calls home know I'm doing it. So we got to do this right. Okay. Number 20, it was an MVMV. I got my little board behind me. So I'll solve it quickly. Gonna move my chair out the way. Right? Where's my marker? Okay. MV equals MV. I did use the right formula. I just combined the things wrong. It's 150 of a 2.4. So it's 2.4 and 150 is equal to X. And then 200 X is equal to 2.4 150 over 200. Okay, and that's going to be equal to 1.8. That's the one that I screwed up. Okay, so the answer is correctly for that number 20, choice 2, 1.8. Moving on to the next question, number 21. The question number 21 asks about the formulas HNO3 and CH3COOH. Remember, the COOH at the end of a formula represents the organic carboxyl group, which is the acid group. So those are both acids. An Arrhenius acid will turn litmus red. Under the litmus indicator on reference table M, it says red to blue. Red is the lower pH side. Red would be acidic. Number 22. When the pH value of a solution changes from 2 to 1, all right? So it's becoming more acidic. However, each change in pH is a change in the power of 10. Remember, the pH value is an exponent. So going from 2 to 1 is going to make it more acidic. So even though the number is going lower, it's increasing in acid value. So the answer is going to be 3. The acidity, the hydronium ion, is going to increase by a factor of 10. 22 is 3. If it goes from 4 to 3, it increases by 10. 4 to 2 is increasing by 10 squared. That's 100. From 4 to 1 would be 1,000, right? Each change in pH is a power of 10. 10 to the first, 10 to the second, 10 to the third. And for the hydroxide ion, it would be the opposite. Remember, it has hydronium. Hydronium ion goes up. Hydroxide ion goes down, vice versa. Number 23, according to one acid-base theory, the reactant that donates the H+, the reaction is, I know some of you probably don't have your books, that's why I'm writing some of them out. It's NH3 plus H2O. I mean, your books were available or were available. I don't know if they're still doing it, but NH3 plus HOH. This H is going to go over here. This is going to lose it. That's going to gain it and give you the NH4 plus OH negative. This would be a conjugate pair, okay? This would be the acid. That would be the base. Okay, so you can look at that. Right? That would make the answer to 23, choice 1. 24. It's another MVMB, but this one is specifically, that number 20 was a dilution. So it's just a general MVMB. You don't have to, they're both bases. It's actually MB equals to MB. Molarity of the base times the volume of the base is equal to the molarity of the new base times the volume of the new base. It's diluting it. Water is being added to it. This one is a titration. It's the same formula. It's MAVA. I have an answer of 12. Okay. If you don't get it, you have a question, you couldn't figure it out, send me a message, and I promise I will answer. I've answered every question that I have gotten. Number 25, the SO4 from the acid goes with the BA from the base. Since they're both 2s, one's a +2, one's a -2, they're going to crisscross and cancel out. Initially, you're going to get BA2, SO4 and then reduce. The answer would be choice 4, right? BaSO4. H2SO4, sulfuric acid, BaOH2, barium hydroxide. The H's and the OH's go together to make the waters. Ba and SO4 go together to make the salt. Okay. Now into the part B2s. Okay, so I can look at my book here and look at you guys. All right. Which solution contains electrolytes? Okay, there's three answers to this. It's A, C, and D. A was KCl. That's a salt. Salts are electrolytes. C, BaOH2, which I said was a base. Acids, bases, and salts are electrolytes. Oh my. And then D, that's the organic acid again. CH3COOH. So A, B, and D were A, C, and D were the electrolytes. B is an alcohol. Carbons and hydrogens with OH make alcohols. They're organic substances. They're molecular in nature. They do not conduct electricity. Electrolytes conduct electricity. The lowest pH is going to be the acid. That would be D. Which solution is classified as salt? KCl. A. KCl is a salt. Which solution is most likely to react with an acid to form salt and water? It would have to be a base. C was a base, the BaOH2. And number 30, the lowest freezing point. Freezing and boiling point depressions and elevations are not going to be included on this test. They were on our previous topic solutions, but remember, chemistry overlaps. We continually review some of our older topics as they're very, very related. BaOH2 because it forms one Ba and two OHs, so you get three ions. Choice B, the alcohol, is only one particle. Alcohols don't break up. And the KCl is clearly 2. Acids are tricky because that acid, CH3COOH, you could write it as an ionization to form two things, but it's a weak acid, so it doesn't break up 100%. So it's almost 2. Okay, but that goes actually beyond the scope of our course. The only thing that you really need to know is that C is 3, and it would be the winner. Right. Number 31. All right. It talks to us about the carbonation process for our carbonated beverages, like Diet Coke, one of my favorites. You might see me have those cans all over the classroom because I drink it all the time. It says that it has a pH value of 3. And then the first question, number 31, state in terms of the pH scale why this is classified an acid. Well, pH 3 is below 7. That's the acidic side of the scale. Remember, 7 is neutral. Above 7, a base. Above 7, a base. Below 7, an acid. Number 32, using reference table M, identify one indicator. There are actually 3. Identify one indicator that is yellow in a solution that has a pH of this beverage. Well, the pH of the beverage is 3. Okay, and we have our handy dandy reference table M. You can see that there are 4 indicators that even use the word yellow. If you look at the methyl orange is yellow at the high side above 4.4, I think it is, right? Yeah, above 4.4. This is 3, so it would be on the red side. The other 3, bromthiamyl blue, bromcresol green, and thymol blue. Any one of those would have been the answer. You didn't have to have all 3. I'm just giving you all the answers because if you had done this in advance, you would have had any one of those 3 answers. And number 33, after the beverage is left open for several hours, all the CO2 escapes. So the CO2 makes the carbonic acid, creates the acidity. CO2 is actually acidic when in a water solution. It forms H2CO3. That's why if you look on reference table K, the second from the last one, it says H2CO3, and right underneath it, it says CO2AQ, which is carbonic acid. That's technically, when you're drinking seltzer, you're drinking carbonic acid. You're not drinking carbon dioxide bubbles. They're released as carbon dioxide bubbles, and then the acidity leaves. But let's say it changes to 1/1000th. That's 10 to the third. It's a change in the power of 3. 1,000 is 10 to the third. And it's becoming less acidic. So that means it has to move up the pH scale. So it's going to go from 3 to 6, closer to neutral. All right, so the answer to 33 is 6. 37. We have titration data, 60 mLs at 0.3. And then we have 42.2 mLs titrated, and we want the new concentration. Well, that's question 35. Question 34 first. It says, what color change does a phenolphthalein undergo? Well, the phenolphthalein is added to the HNO3. So on the acid side of phenolphthalein, the lower pH side, it's colorless. When it goes to the higher pH side, which is above 9, okay, that's going to be pink. So it's going to go from colorless when it's in the acid. Acids are below 7. That pH change is at 8. So the acid is less than 7. 8 is less. 7 is less than 8. So it's going to be clearly colorless. And then during the titration, it becomes neutralized. The pH goes up to like 10 or 11, whatever it is during the neutralization process. It changes to pink. So it goes colorless to pink. And when you do the MAVA is equal to MBVB, it's 0.3 times 60, right? The MA is 0.3. The milliliters is the volume. 0.3 times 60, and it becomes X is equal to 42.2. X times 42.2, rather. You get an answer of 0.43. Actually, it's 0.42 and change. I don't remember all the decimals I did this time so I don't screw up as much. Put my answers down in advance, and I have 0.43 written here for the answer. So that's more than likely our answer. Okay. And again, remember, if I make a mistake on any of these, I'm human. I make mistakes. Just text me, email me, and I'll fix it up the next day. Number 36. Right. Number 36 and 37 is kind of a prelude to 38 and 39 because they show you the data. I actually did like a mock titration with you. I don't remember. I brought out a burette and I started it at 0. Then I drained some out. We read it, drained some more out, and then figured out the new volume. In questions 36 and 37 in that data table, the new volume by subtracting the initial and final volumes is provided. In numbers 38 and 39, we're going to have to do that. All right, be that as it may. The calculation for the molarity of the KOH, I have 0.97. Okay. That's going to be, student user, it's 1.4 times 15.4. 1.4 times 15.4. That's the MA and the VA. The MB is the 0.97, which is X. And then the VB is 22.1. And then we solve and get 0.97. And then it asks, well, why would we do this multiple times? Well, we actually never got to do this lab, but when we do the titrations, generally I do titration of vinegar just so you can learn how to titrate. And there's actually someone out there with a job that says, hey, we just made vinegar in our vinegar factory. Test if it has the right specifications for our customer. Vinegar is supposed to be 5%. You're going to have a person who's testing the vinegar and making sure it's 5%. And they do the titration, just like we've talked about. And they'll test each one probably at least 3 times just to make sure it's accurate. And they'll take an average. So the more you do something, the more accurate it is. Okay. 38. The first thing you're going to have to do for 38, okay, is get the volume of acid and base used. I believe it's 3.8 for the base, and it's 9.5 for the acid. And then we're going to do our MAVA. And son of a gun, I didn't work out the answer. You know what? I think I did it on the calculator. I didn't write it down. You know what? I'm going to do a few more of these tomorrow. You're going to have to take the test, but I'll make another short video, maybe a 10-minute video tomorrow, because I know I'm going to get some questions tonight. So I'll put the answer to 39 in that video, and whatever else I have to deal with because people ask me questions on Monday. Number 40, identify a possible pH for rainwater. Got like 4.5, right? The two indicators here were methyl orange, and methyl orange was yellow. That means it has to be above 4.4. And then litmus turned red, so it has to be on the acid side. So I got 4.5 for a logical answer. Litmus actually changes to 4.5 to the red, so it's right around there, right around 4.5. Number 41 explains in terms of hydronium ions. There has to be more hydronium. It's an acid. Acids have higher level of hydronium. Bases have higher levels of hydroxide. They're in both solutions. Hydronium and hydroxide are in both solutions. In neutral solutions, they're equal. In acidic solutions, hydronium is more, hydroxide is less. And in basic solutions, hydronium is less, hydroxide is more. Right? Takes me to 42. 43, it's three significant figures. That 0 in the 35.0, they don't need to write it. Why did they write it? Because they actually measured it and found it to be a 0. Okay. 44, it's HNO3 and NaOH. So the H goes with the OH, that's your water. And since it was HNO3 and NaOH, it's NaNO3. Let me write that out. I'm going to write that out on my board. NaNO3 plus HOH. Because it was HNO3 and NaOH. There's the H from the acid and the OH from the base. Show a correct numerical setup. I'll write that down. I got to clean my board. I'm going to go a little over what I usually do, but I'm going to get them all done. And then just ask me questions tomorrow, and I will answer anything you want. Okay. Write your formula. MAVA is equal to MB. This marker. I gotta go out and get more markers. See if any of the little expos work. Okay. It's X 35 is equal to, technical difficulties here, 0.15 and 30. I need markers, man. I gotta go out and get markers for 0.15 and 30. Okay. All they ask for is a setup, so you don't have to solve anything. For the graph, it's going to look like this. It's going to go up, and then it goes sharply up, and then points out again. At this point here, none of these things right, man. Sorry, guys. I don't want to have to do the whole video over. There we go. Right here, that's called the inflection point. That's where it's neutral. If you look at the data, it goes 10, 20, 24, 24.9, 25.1. Within a change of 0.2 mLs added, it jumps from a pH of 3.9 to 10.1. That's right here. That's at 25. That's where neutralization occurs, and then you have the most rapid change in pH. So if you graphed it out, that's where you would see the inflection point. That's about 25. When we solve this, the correct numerical setup, I don't know if it asks for the answer. I think it did. It's the balanced chemical equation would be NaOH plus HCl yields NaCl plus H2O. And then when you do the MAVA, you're going to get 0.05 for the acid. That's the last answer. I definitely went a little bit longer than I usually do, but I finished. I will answer any questions tomorrow. I will put up a short video tomorrow. You have to take that test. I know a couple of people did. The rest of you got to get it done tomorrow. If not, I'm putting in zeros. Okay, there's one person I spoke to that did it early and didn't answer questions. I'm going to give them another test. The rest of you have to take it tomorrow. There's no excuses. Okay, we had another circumstance happen there. Okay, so guys, have a good night.